It obviously fractured the rocks in a very regional way. It produced the global dust layer, which is how we tracked down this event to this location. But it's since been buried by about 1 kilometer of tertiary sediment. So it's sort of hidden in the subsurface, and there are some boreholes that are nearby that have been drilled from into the deposits, but most of what we know about the crater itself and the impact has come from remote sensing, like this gravity map that's shown in this figure. And there really are only a few near boreholes. Computer doesn't like this.
Lower left corner, maybe?
I think this is an autosave, but while this is the boreholes that are nearby are shown in this illustration in these triangles, and there are 3 of them that are inside the crater. These have more than 500 meters of ejecta deposits that are in them. But if one then moves from there to the nearest deposits that are exposed on land, that little blue arrow points out where the first deposits are of this event. They're 500 kilometers further to the south, and at that site, I guess some sort of colossal failure here. At that site, those deposits are on the order of 10 meters thick, 500 kilometers away. And the deposits consist of fragments of limestone that have been apparently blown through the sky because they're not on limestone deposits, and they're held in a matrix that came down of sort of siliceous material, which is part of the crust that was melted away in the area. Now, if one then goes on the other side of the Yucatan platform and look at the deposits that are on the floor of the Gulf of Mexico, one gets into a scenario where those deposits are known to be up to 200 meters thick. This was discovered from some of the early deep-sea drilling project drilling in the floor of the Gulf of Mexico. And these are basically fractured, shallow water limestones. The source of these is believed to be the Campeche Escarpment. And if we then look at the distribution of samples in the Gulf of Mexico and follow recent work by Dene et al., it turns out that something like 43 to 115,000 cubic kilometers of material fell off the escarpment face in this particular event. This is the largest landslide deposit that is known on Earth by a factor, by order of magnitude. Really big event. I would also point out that that star down in the lower corner is the Reformer trend in Mexico. This happens to be one of the giant oil fields in the world, and they're actually producing oil from breccia that was associated with the Cretaceous Tertiary landslide deposit. And then if one thinks about what happened that day, there presumably was a massive shock wave that propagated down through the ground. It would have reached the edge of the escarpment within seconds of the impact, and presumably it blew off a section of the escarpment face. The curious aspect of this is if you calculate how much of the escarpment face must have retreated in order to have generated these deposits, it takes something like 10 kilometers of the escarpment face to have retreated in this event to generate these deposits, which is a huge volume. Now, that is the curiosity part of this. We have been interested in finding these deposits, getting closer to it, and sampling nearby to learn more about what happened in this event. The reality is the existing bathymetry before this effort was completely inadequate to launch a modern expedition were based upon the satellite bathymetry that was the best that was available at the time, and simply had no way of knowing whether there were going to be any outcropping sequences there or at what level to look. So that was our goal at the outset, and during this cruise, we mapped a 635-kilometer long section of the escarpment. This is equivalent of mapping from the Big Island of Hawaii to Kauai, and it's really an area of spectacular relief. I'm pointing out as that goes by, you're seeing something like 80 submarine canyons. Before we did this, we only knew of 3, and this whole face is all carved up with major canyons. Now, getting back onto the topic, though, of where the KT deposits were, it happens that fortuitously, the deep sea drilling project in 1971 drilled 2 holes on top of the escarpment. And this is a great example of sample and data archiving that was done where the information about this drilling is well recorded. And at the time, they had no idea that there would be interest in the Cretaceous boundary in this area. They drilled through holes on what they thought were gullies on the face of the slope, drilled down through a nearly continuous tertiary section into these deposits that were hard drilling. And they got less than 1% recovery in the samples drilling into this, but it considered chips of Cretaceous limestone, so we know that they got into the Cretaceous of that, and it had this fused material in it, which we now know are probably ejecta or metamorphosed samples along the escarpment face. Now, if you then project where these boreholes were drilled, onto the multi-beam data that the Falcor collected, one finds that at the level of the top of the Cretaceous, just projected a very short distance, one finds that there's a distinct break in slope along this escarpment face. And it corresponds remarkably well with this. It's steeper below this break in the Cretaceous section. And the same thing happens at the other edge of the escarpment. And based upon this, I think we know where the top of the Cretaceous section is there, outcropping to very close a level. Now, like any data set like this where one collects a lot of information and maps a big section of it, there are all kinds of curious things that are going on. One of the things that we've discovered in this is there were large landslide deposits that are also in the tertiary section. Other people are now modeling these landslide scars as being possible tsunami generators for things going into the US Gulf Coast. I myself am particularly interested in these box canyons because they're rather bizarre. There are about 80 of them. You note that this canyon has no central valley to it. But the reason I'm showing this slide is the floor out in front of this escarpment is filled with flat-lying sediment. This is the Mississippi river fill, and it has accumulated about 3 kilometers of sediment and burying most of the base of this escarpment. Happens that there are a few places where there's an apron out in front of this escarpment face where there's some big blocks, and the block you see in this screen here is more than 10 kilometers across, and those appear to be pieces of the escarpment face that have not been buried yet and are telling you something about the size and the scale at which the escarpment broke away. Now, I think that this cruise got us exactly what we wanted to know. We wanted to know where the face was so we could go back and sample it. There are clearly outcropping exposures that are available. I think we know the location of the KT boundary here within probably 50 meters in X, Y, and Z and the like, and it is providing us a roadmap that will allow some group to go back and make it available for sampling. I think it's obvious that this data set is going to make some group will do this at some point. Now, I make another comment, and there's a lot of interest in the data handling here, and it's an interesting experience of doing the data sharing. We have provided this data to Google already. It's up on Google Earth. If you scan it in on the escarpment face, you'll see it's now one of the best map sections of the world. You have to zoom in on it in order to see that, but if you wanted to work on the escarpment, there it is, it's available. We've also provided the full swath data already to 3 groups. One of them includes a group in the USGS that we're actually not explicitly working with. We've got the full data, and 2 groups in Mexico. And we have a personal goal to get these data to the national data centers before AGU this year, so we've fully released the data.